I was wondering as to how it would be if our laptops could automatically change brightness depending upon the ambient light, just like our mobile phones and tablets and all other smart devices. So this project is an attempt to address the issue and try and make my laptop change its screen brightness automatically depending upon its ambient and surrounding light. So let's get started. Before getting started, I would like to thank the sponsors of this video, JLC PCB. JLC PCB offer excellent PCB fabrication facilities to help budding DIY enthusiasts realize their dream of making projects. They offer a number of different PCB fabrication options for incredibly low price and a low turnaround time. For more details, make sure to check out the link in the description of this video. Normally, on all your smart devices, be it the phones or the tablets, on the front, beside the selfie camera, you will have your light sensor. So this sensor picks up the intensity of the ambient light, and then this changes your screen brightness depending upon the intensity of your ambient light. Usually the sensor that is being used is nothing but an LDR. So LDR is a resistor whose resistance varies with the intensity of light shining on it. Say, as the intensity of light increases, its resistance decreases, and as the light intensity on it drops down, the resistance offered by LDR increases manifold times. So we'll be using this property to build our laptops auto brightness changing circuit. So here's the list of the parts that I made used in the project. So first one is a 100 kilo ohm resistor, and the second one is a light dependent resistor, or the LDR, a very critical component, and then the add-ons like the PCB and the headers. So other critical component is the Adafruit Trinket M0 board. There is a reason for me choosing this board. See, once you pick up the voltage difference arising because of the changing light intensity on the LDR, you need some kind of an action to be initiated on your PC or a laptop. So this has to be done through a device that supports HID. So there are a very few number of Arduino boards that supports HID. So one among them is the Adafruit Trinket M0. So this is the general circuit that is normally used for LDR based sensing. So you normally replace the R2 shown on the screen with your LDR. So as the resistance across the R2 or the LDR varies, the output voltage or the Vout also changes accordingly. So let us take a sample over here. So the voltage supported by the Trinket 0 is 3.3 volts. And as I mentioned before, the resistance or the fixed resistor value is about 100 kilo ohms. You need to know two resistances of your LDR, that is the resistance of the LDR at zero light intensity and the resistance of your LDR at maximum light intensity. Either you can find these details in the datasheet of the LDR that you just bought or buy, or you can find this by manually testing it. Just use the probes of your multimeter across the terminals of your LDR and then try shining the light on it. So in my case, the LDR's resistance at maximum light intensity was approximately 30 kilo ohms. So I get an output voltage of approximately 0.7 volts, and I found the resistance of the LDR at zero light to be approximately about say I would say about 1 mega or 1 mega ohm. So that approximately comes to about 3 volts. So this is a very significant change, that is the voltage across our LDR or my LDR changes from approximately 0.7 volts to 3 volts. So this change is really significant and big enough to partition it in equal levels and then change the brightness of your screen accordingly. And so then I built the voltage divider circuit on the general purpose PCB, and also soldered on all the female headers on the general PCB and the male headers on the Adafruit Trinket IO board. So in order to mount the circuit or the board onto my laptop, I used a piece of Velcro both on my laptop as well as on the board. I know what you guys are thinking. I'm not a fan of this man, but unfortunately the Velcro that I used resembles this guy's mustache. And so then I assembled everything together, connected the board to my laptop, and ran a sample code to check for the change in voltage across the LDR with varying light intensity. So as you can see now, in total darkness the voltage is approximately 2.4 volts, and it keeps decreasing as the light intensity increases, and it is approximately 7.2 volts in full brightness. So this is the value that we actually calculated before using the voltage divider circuit theoretically. And so then I created PowerShell scripts, 10 different PowerShell scripts for the varying different levels of brightness, starting from 0 brightness to 100 or the maximum. So if you take a look into the PowerShell scripts, we are actually setting the monitor brightness level using these parameters. So I used a similar script for all these values, and after that you actually need some kind of a means to run this PowerShell script. So I created a shortcut which on double click would run the PowerShell script, and also assign the shortcuts. Say for example, for setting the brightness value to 10, I used a shortcut key of Ctrl Alt and 1. So in the target value for the shortcut, the PowerShell script path is assigned, following by the arguments, and that is pretty much it. This is the kind of a pattern that I followed for all the sets of different PowerShell scripts. And so here is the piece of the code that I wrote. So as you can see here, I am continuously checking for the voltage across the LDR values, and if I find a change in value of the LDR voltage, that is if the value of the new LDR voltage is not equal to the old one, and then I am initiating an action. So as you can see here, I am executing the shortcuts for all the PowerShell commands using the keyboard press and the keyboard.release command. So once this code is loaded onto the Adafruit Trinket M0, everything is almost done. And now let's take a look at the demo of automatic change in brightness on the laptop.